we take a look at some of the newest and most incredible electric motors. Starting at number 5, the Yamaha Motor Unit. Yamaha is finally accepting orders for a all-in-one 350 kilowatt unit intended for high-end EVs and possibly full conversions. The gearbox and inverter are integrated into one unit, and this uses either oil or water for cooling. The unit tops out at around 500 horsepower at 800 volts, but it's designed to be in conjunction with another unit, which would make it to be one of the most dominant all-in-one packages on the market. As of right now, the company has showcased several prototypes, but once again it comes down to how affordable these units will actually be, and obviously they won't be anything revolutionary in terms of actual motor design. At number 4, the MAHLE contact-free motor. The incoming EV race will bring a few notable problems. One of these problems is material supply for both motors and batteries. Magnets are particularly problematic because they are used quite a bit in motors, and obviously these are built out of rare earth metals. So this company has decided to build a motor which actually doesn't have any magnets. This means that there are no contacts to transmit electricity, abrasion, or mechanical wear for that matter. Power is actually transferred wirelessly into the rotor via induction, therefore producing an electromagnetic field. Now, MAHLE has been pretty transparent about the design, and they stated that it could be used for lighter vehicles, but it would probably need a transmission for heavier trucks or even lighter bikes. Mass production is also about 2.5 years away. At number 3, the 250 from H3X. Now, this is a very intriguing motor which utilizes 3D printed copper coils and synergistic cooling to cool both electronics and the motor. This allows for a lighter and more compact design which can achieve 20,000 RPM at 250 kilowatts. H3X claims that the motor can achieve 13 kilowatts per kilogram, but we should be skeptical of this claim because that would mean it would outperform high-end axial flux motors. I'm not saying that this is totally impossible, but it's a pretty bold claim and it will be interesting to see what the real numbers are. We do know that there have been new copper 3D printing techniques which can allow for better geometries and obviously better motor designs. So we'll just have to wait and see if this company can actually build something which is next level. At number 2, the Churnchide motor. Now obviously reluctance motors are nothing new, and they were invented back in the 1800s. They have been used in a lot of industrial applications, but they are also known to have a lot of vibration issues, and obviously they are very noisy. Reluctance basically means the resistance to the magnetic flux. So the current is constantly switching, and each rotor pole is pulled towards the approaching stator pole. Now this motor is definitely reliable, but it's very tricky to switch the current at correct time intervals. So Churnchide has revised this design by increasing the number of rotor poles and creating a sensorless algorithm. This allows the current in the coils to be switched at 20,000 times a second, thus increasing efficiency. Now, this variant is relatively new, so it's going to be interesting to see the power to weight ratio, and whether or not it can actually branch outside of industrial use. So the question still remains on what will be the dominant motor design for electrical vehicles in the future. The majority of motor designs, which I have talked about earlier, are radial flux, but a newer type of design will likely take over the high-end market. The yokeless axial flux motor is only developed by a few companies, which includes the Magnax motor. They have achieved 16 kilowatts per kilogram, which is over 3 times the power density of a Tesla Model 3 radial motor. The axial flux design has been known for some time, and it has a shorter direct flux path. Therefore, it has a stronger magnetic field, which is why the motors have a really good power to weight ratio. Now, the axial flux is a pretty challenging motor to build, but Magnax has claimed to solve the production issues. Ultimately, their motors should be out on the market in just a few years. Now, another neat development which is worth checking out is the Neodyne magnetic transmission. They have shown some really neat demos of their 160 Newton meter gearbox. Obviously, it's not 100% efficient, but it can handle 10,000 RPM with very little noise and friction. Now, this type of design could particularly be useful for wind power or even electric boats, which brings us to the number 1 position. So probably one of the most unique designs out there is the Deep Speed Hydrojet. This weird open-ended hydrojet is an all-electric propulsion system, which can be pretty much mounted like an outboard motor or as an independent 360-degree pod, which can provide reverse or sideways thrust. There are no gears, shafts, or universal joints. Only a pair of wires running from the batteries to the hydrojet. Now, obviously you have to consider the weight of the batteries, but the base model only weighs 75 kilograms. So it can be considerably lighter for short-range applications when compared to combustion engines. Now, the rear design is kind of like a turbofan, and it funnels water into the front and accelerates it out the back, meaning it's highly efficient and it accelerates faster than a propeller. The company is working on multiple variants ranging from 100 to 780 horsepower. Ultimately, the Hydrojet has already shown some very impressive demos, but we will see if the crowd-funded motor will really make waves in the future market. So once again, thanks for watching. Please like the video if you enjoyed it, and make sure to subscribe to my channel.
Telefono appoggiato al... Sì, sì,